I had intended to do this in class, but we didn't have time. So I want you to, some of you have this already done, accuracy, precision, we need the average, we could do it separately. We need the standard deviation. It's good to know for sure what our count is. And that should do it. Precision generally is the relative standard deviation, otherwise known as coefficient of variation. I've cleaned up my chart here. I made all the columns the same width. You can squish them and adjust individual ones or adjust all of them. Anyway, okay, so how do we do this quickly and efficiently? Well, let's do it according to the information that we need. So let's start with the average. You enter the formula, and just after you enter that left parentheses, I hit the down arrow, and I just go down until I get to the top. Then I hold Shift or Control first, Shift, holding those two, hit the down arrow, that goes to the bottom and stops. And if I say enter at that point, that's the average. Now, right off the bat, you could go down here and start typing equals STDEV. But when you get to entering the range, you're going to have to jump down here and do that same thing. Well, let's save ourselves some trouble by clicking up here, or once you get this down here, and you can get that by double clicking, or you can get that by F2. Once you get that, click right there at that parenthesis, select that, Control C, copy it. It's in the clipboard. It's not the same as copying the cell. It's copying a part of it. Now we type STDEV, Control V. Put that in there, and notice the same range is selected. You should know what would happen if you tried to copy and paste, well, and then change the word. Never mind. Okay, so this is the count. Control V, enter. Now, that's all we did. But if you were doing a lot of formulas here that all had to go down there, that's a good trick to know. Okay, precision. Relative standard deviation is equal to the standard deviation, just click on that, divided by the average. So in this column, the precision equals this standard deviation divided by this average. Okay, and I already have that formatted in percent. It doesn't usually come like that. You get up here, the automatic formatting for this is a decimal. And so never, never, never multiply by 100. Don't do that. Instead, click on this little percent. Okay, and then accuracy is our observed result average. Let's call it the average minus the true divided by the true value. And we call that percent error. F2, notice that? And we talked in class about this formula, which goes first, the average or the true value. I like this way. The average minus the true value that we're expecting was a 1, close parentheses, divided by 1. And once again, I had this formatted. I deleted this already once. Okay, so you just do one column of formulas, then click into the top or the bottom, hold the shift key down and go wherever you want to go with the arrows. But if you just step down with the down arrow, and then copy that, Control C. Click out here, but actually you could just stay here, I think. I'm going to try this again. Just escape a couple times, hold the shift key down, walk down with the arrow key, Control C, copy. Now just hold the shift key down and go over. But what I wanted to show you is, see, it's still holding it in the clipboard because of that blue line. If you start here, you only need the top row. It knows to copy that down through all the columns. And now you see everybody's summary of average, standard deviation, precision, and accuracy. Now, I like all of these 2 decimal places. That's how I formatted that. I think that's perfectly alright. Okay? 2 decimal places shows the differences here. Any more decimal places is giving us a false sense of the importance of our numbers. Okay, now today we added averages for these, and here again, same pattern. We can say equals average and begin parentheses, step over 1 and hold the shift key down and walk over and say enter. Now I walk back up with my arrow key, Control C, copy, hold the shift key down and walk down and say Control V to paste. So the average of all of these numbers in each row to the left is shown under average, and then we want to be able to see what we're talking about over here right next to what it is. So I click into this column to the right of it and say equals, and then just walk over if you want to the word accuracy. Once again, Control C, walk down, Control V. Now, if I had started knowing that I wanted the word there, I could have walked over with that, equal, and walk over with this, and copy them both, Control C, Control V. I'm just showing you that there's shortcuts, and you really don't learn them until you've been 16 times you've done the same thing, and each time it took 27 steps, and you finally realize you can do that all in 6 steps, and and you need to get done and get home. So you learn these tricks. Uh, Now, when we get this far, we're not by any means done. You know, we've got differences between people here that are um, sizable, and we need to now be able to go down into this data sets and pull out answers, pull out measurement values that are not normal, or that we want to see why things are pulling one way or another, and it's going to have to look at the data more than just as an average and a standard deviation. These values are meaningless unless we're talking about the normally distributed portions or parts of this data set. Our goal now is to make sure that when we use these standard deviations to make predictions, and we need to make sure if we're talking about differences between people here, that these numbers are not being pulled one way or another by some one or two results that are out of whack. You'll see. Okay, so and I'm just going to jot down here. We have looked at our data in a couple different ways. One is a series type thing where we have an x value that goes along a graph at a certain y value height. Okay, on the x-axis we've got a x value, and the y's go up and down depending on their levels. That's a series chart. And then we have another chart called a histogram, and we've done them two different ways, but we really only need one way of doing them, and I'm going to do them by the method 2, we'll call it. Okay, so we want to look at the series because that sort of gives us a feel for this is one thing after another that we did here. First, second, third, fourth, fifth. And a lot of times things go differently at first, and once you get the hang of it, you see how you get better. And if you wanted to know your precision, you'd want to sort of focus on the better part, because that's what you'd expect in the future, that you wouldn't have to go through a learning curve every time. And training that is a part of quality control would really have you ignore the first part, ignore the training when you were not trained, and use the precision that you can achieve after you're trained. So keep that in mind. So we'll look at this series to see how your measurements went over time, and then we look at the histogram to see which measurements seem to be part of the normal distribution. And even if someone's precision is very much different than someone else's, if this is normal for this person, then we stick with it. This is what we expect of this person. Or this person looks at his data and he sees that, oh yeah, this is what happens when I have the pipette at a 45-degree angle, and everyone else is consistently holding it at a 90-degree angle to the thing that they're putting the water into. So that's part of the training and part of the cycle of continuous improvement. You plan what you're going to do, you do what you're doing, and then you study what you did, and you act, you change your plan, you go through this cycle of improvement. Okay, now how do we make the histogram of all this? Well, we're going to use method 2, and so what do we need? Well, actually, let's do the series first. And how do we do the series? We need an x-axis list, and this is the x-axis that we want. We don't want these numbers in here. I'm going to just get rid of this. We've got those numbers there too. Okay, so I'm gonna hold Control Shift down to show you what that does. Is it? And I went. Oh, this is a merged cell. We want to unmerge this cell. So I can't find an option in this right-click menu, so we go up here and see if we can find it here. It's in format, merge, unmerge. Okay, and it disappeared. Huh. Okay, so now I'm gonna just do what I'm trying to avoid telling you to do. I'm gonna Control X and just step over to the left. I would have thought that it would be at the top there, but in any case, Control V. And we don't really need that at all because it's just repeating what we did. We just wanted to make sure we knew what we were doing. And I'm going to delete all of this. I would like you guys to do this. What you see I'm doing. I deleted with the delete button, but I really Control, Edit, and then see that D right there is underlined, D. That gets rid of all that formatting but we did lose this description. This is deliver using a P1000. Okay. There again, we have to unmerge, and we can't do it with that. I think you can, but I'm not finding it. And when we merge, it deletes what we said there. I'm surprised. Okay, deliver using 25 ml by pattern. Okay. Index is what I'm going to call that. Control X, I'm going to cut that out and put it over here. Cut this out. Control X, Control V. And notice we have a little column in between C and A there. One way to get that out of there is to select the tops and then adjust any one of them while it adjusts the whole business. And there, oh, that was squeezed in that column somehow, right? Somehow. So anyway, let's delete this column. Alt Edit D, Alt Edit E deletes a column. And now we can squish this up. Anyway, I'm not concerned about this too much, but it would be good to neaten them up. Let's move all of this It's not bad to see how to do this. All I need to do is click in the upper left corner, Control V, and that's what's that there. Now with that big thing here, you can format either the single cell, let's just do that, and wrap that text. Okay? Then we don't need this column. I want to get rid of that, so actually you can hit E again, or you only need to be in one cell. You don't have to select the whole column. Alright, now I'm asking you all to do that, all of those steps in terms of getting your data set into a nice thing with a column of X values and a block of your data from everybody. And I mean, there's no reason to be self-conscious about these values. This is the way it occurred. We are all humans. We should be proud of it. We're miracles of creation, creatures that are conscious of their existence, and even conscious of their consciousness. It's incredible. It is absolutely incredible. Okay, so you select the data, including the header row of names on the top. We go up here to chart. What type of chart are we going to get from this data set? Here we go. Okay, we see, oops, we see, then that's perfectly fine. That's what I want. Y values on the top, X values across the bottom. Good enough. That we'll call our series. I just am calling it this, and you can be creative here, what you think is best. 1 ml deliver with 25 ml pipette. And this we can get into with axes, left vertical axis, labels. Title is the word, labels is the numbers that go there. And they give you pretty good control. So what did we really measure? The weight in grams of 1 ml. Delivered, obviously, so delivered to the balance. Okay, there we are, and then each person's. So you see, nobody's really different, are they? Although there are some people that were closer in. Anyway, this clearly is not a number that we want down here, but the rest of it, I don't see any clear evidence. Now look at Bill as far as the learning curve goes. You could imagine presenting this data in different ways in terms of, that goes up and down. You could say, well, let's just subtract his deviation from the average and plot its absolute value, and so you'd see a high number to start, or at least it would be up in the high range, and then it would come down because his deviation became less, and so it would always start high and come down. That might be called the learning curve. Whereas this is called I don't know what it's called, the noisy up and downness of the initial period. sometimes more, sometimes less volume was weighed. You know everything I'm telling you. I'm just trying to give you the instructions, which could be a much shorter version, but you're not going to get the point. We don't want to separate the skill that you're learning from the reason why you're learning it, right? Okay, so there's our series. Now we want to do the histograms. I think I'll try and put this down out of the way. We'll put it right there. Should be fine. Okay, so what do we need for the histograms? We need a bins list, and we need to go from the lowest to the highest value in any of our data set. So actually, let's add by Alt-I and I think R, row above. Let's add a row above and another one, and add to our thing here the maximum value and the minimum value. And we have to go through this again. Max, I'll step down when I get here, Control Shift down. And why not just save ourselves a trip? Control C, click here, equals min, Control V, enter. And it's formatted as a percent. Let's make sure we just only have to do this once. Okay, then we copy these two, and whoa, Control V. I don't know how we had those. We just had that one row. Okay, well that's cool. So the lowest, and actually we could do, we could just, we don't want averages of the max and the min. I don't think there's any need for it, but we could just do max here. And we could either find the max of these maxes, or we could do the max of our whole data set. Control, Shift Control, arrow. Control C. I don't like having to coordinate my eye and hand to click into a little tiny thing is really, sometimes you get it. So notice this 0 is really what is contributing to this big difference of what looks like terrible precision is a single value pulling that down. I'm just going to delete it. That was probably a mistake. Maybe I changed it somehow at some time. And now look, you know. So, and we're going to look more carefully now at this data with the histogram and don't go anywhere. Okay, so now we see how we need to make our bins. We need to start at 0.6 and end at 1.4. So let's put a 0.6 here, and let's just say we're going to go up in steps. Whatever's going right where I am is going to equal whatever was one row above it plus 0.1. And so let's make sure that we formatted the whole thing the way we want it. And then we just Control C, hit the escape button when you make a mistake. Control C, copy it, and just step down till you think you've covered the range. And that's more than enough. It's always good to start a little below and head a little higher. Okay, now we're going to set up our frequency things, and we're going to want to name at the top. So this equals in here whatever this name was, and we're going to stop there for now and enter the frequency formula and begin our parenthesis. Click over here at the first data point, hold the Control, the Shift, and hit the down arrow. Enter. Oh, we didn't give it the bins. So click into here or double click here and click right after the 3 before the parenthesis. Add a comma and then give it the bin list. So click there, hold Control Shift, hit that. Now hit enter, and there we go. Now all we need to do is copy Doug and his formula. Control C, hold the Shift key down and walk over, but we really only need that. I just show you that so you don't think you have to match the pasting range at any point other than the top. And I screwed that up, but I'll just come back. I'll show you. You can paste over the top. Control V, it doesn't hurt to redo it. And you can go beyond over here and just select it and delete it. Now, why did this numbers all come down here? We're counting. Okay, well, you know something's wrong. What's wrong is the bin list is in column M, and when we copy to the right, we see Jason, Doug moved to Jason, but the bins moved from column M to N because we copied everything relative one column to the right, so it looks to the column to the left of it for its bin list, Jason's frequency formula. So we want to go back and just say, okay, well, if we put a $sign right there, the $sign makes that an absolute column. The column won't change. And now we enter that. Doesn't change for Doug, but we copy it again and paste it. And now the distributions, the counts are all in the middle of the regions. That's what we want. Now we want bins on the X for a histogram, frequencies on the Y, and we can put them all on the same histogram by using the column chart type. You have to wait a minute. Now this is what we've learned so far. Pick a column chart. And now that's okay. Notice they did put bins here. Okay, so it's not bad. The labels. This is a column chart, and we want to call it a histogram. Students pipetting 1 ml with 25 ml pipette. And what's a label on the y-axis? Oops, not the label. Title. Frequency. You have to kind of think a path. Where did we get frequency? We counted how many of the numbers in this measurement of the grams fell in this weight region here between point 0.8 and 9. We count 1, 2, 3, 4. These lines always stop at a whole number, 4 or 5. This one's 6, 6, 5, 6, 7. Nobody had 8 of anything. Okay, so that's hard to see, those little lines, and it's hard to really follow any individual student here to see how their precision looks. So here's what I'm thinking will work. If we click out of the chart, click once in the chart, right click on the chart, doesn't give us the option I want. Copy chart. Or maybe just click on the chart and hit Control C, then hit Control V. Now we've made a copy, and I want to use the copy to show you the other form of a histogram or a frequency distribution. That's simply a line graph of the same information. It's easier to look at when you have a lot of series on the same chart. And I think, you can do a lot of these steps in the editor here, either way. This is called a frequency polygon, and everything else is good here. Okay, so this is probably the preferred method of looking at our data when we have a lot of series. Okay, now I don't see anything in here that's really not consistent with normal variation. You might question, is this outside of normal? Well, we'll get into that in class. You don't need to hear everything to be able to do your homework. That's what you need. So here's what I'm thinking I want you to do, but you'll see it written. I want you to do what I just did for this same data set in your workbook. And, I've told you, you have access to this file. You could just come here and cheat. You could say copy Mr. Owl's file to my workbook and I'll give you 10 points. But I'm never gonna hire you to work for me. You hired me to work for you now, remember that. And I wouldn't be doing the right thing if I let you get away with it. So I'm gonna build into this page some little tricks. I haven't thought of how to do it yet. That if you copy and paste this into yours, or you try to avoid doing this work, that you must do because you paid me to force you to do this, so that you would become educated in spite of your resistance. It's painful to make those neurons connect. It takes work, it takes effort and willpower. And so if I catch you cheating, I'm going to report you to the dean. Alright, so you've made these charts. You can try to arrange them. Actually, we could delete. Let's just delete the histogram. We can switch back and forth with this to column chart very easily, by doing that. Actually, no. But that's really what we want, is a frequency polygon there. Okay, So I want you now to do the same thing. Insert columns as necessary. Rows, insert rows as necessary. And now I encourage you to do this the easiest way possible, but do it yourself, not by copying from me, but by copying from what you have done. And the trick of that is to go over here, and you might as well copy this whole thing and come down here and paste it. But you have to paste it somewhere here at just the right point, so that I'll just do it, where the formula goes to a position. See how that comes down here? It's not hitting the right place. So the important thing, and I hit Control Z now to undo all of that. The important thing when you copy and paste is to make sure the upper left corner of what it is that you're copying relates to the data, the positions in a relative sense. 1, 2, 3, 4, 5, 6, 7, however many rows it is below that formula refers to. When you paste it here, wherever that formula is, it needs to go the same number of rows. And I'll just let you do that. I could show you, but it's something you have to figure out, and you can do it. Then, when you're done with that, I want you to come over here and do the same thing for last year's class and compare their results to your results as a class. I want you to practice. There's just one data set, the one we just did. Practice adding your formulas here. Actually, just go ahead and add your rows, copy and paste. And where you need to go a little more to the right, you're going to have to pick up. It depends on how you copy and paste. You only need to do one single line of formulas, copied and pasted across the whole range. See, I could go Control V and accept where I copied over things that are irrelevant. Now these numbers are going down into the histogram frequency table and applying the formulas, but you only need to copy one column, and then you could come over here into these volumes and use that by pasting it all across the top, so long as you've added enough rows that the formula comes down and refers to this data. I think you'll understand that. Okay, that's your homework for Tuesday. For Thursday, April 6th. And then we have a spring break. And if you do this assignment, you deserve a break. If you don't do this assignment, I don't know. Speaking of miracles, here's the software I use for editing the videos. And this was the recording, and what you see here, these little spikes, are my soundtrack. These are the words that I spoke, and this is zooming in. And if we really zoom in, we get to, if we can't, this is just a display for purposes of editing, but if we could zoom into the digital level, you would find little points on the y-axis here that would indicate the O's and the ones that are being digitally recorded by my voice. And if you think of the information that gets conveyed to you, to your brain, by the little O's and ones of this data digital recording, and think of it in terms of histograms and lines on graphs and data for measurement, you have to admit it's an incredible phenomenon. And we are the only creatures in the universe that we know of that that can do this. It's incredible.